welcome message from the Rector of Manado State University, represented by Professor Dr. Mr. Gideon Maru Embun as the Vice Rector for Academic Affairs. Please welcome Professor Maru.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, salam sejahtera buat kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. The Honorable Chairman of Senate of Universitas Negeri Manado, Profesor Sumual, and the Honorable Vice Rectors on Students and Alumni Affairs, Dr. Leni Simatupang, and the Honorable Chairman of Research and Community Outreach Institute Universitas Negeri Manado, Dr. Armstrong Sompotan. One of the committees, the steering committee for these public lectures, and the host today, the Honorable Dean of Faculty of Math and Natural Sciences, and here Professor Yermia Mokusuli, the one is working with Dr. Armstrong to make these occasions possible. And we also have the honorables deans from several faculties. We have Dean of Faculty of Economics, Dr. Shady Watung, and also we have here the Dean from Faculty of Education and Psychology, Dr. Aljon Dapa. And we have here also Dr. Alfred Makadada, the Dean from Faculty of Sport and Public Health. And we have here also the Dean from Faculty of Language and Arts, Dr. Grace Lentungan. And we have the Chairman of the Internal Monitoring Board, Dr. James, here. And we have the Dean from Faculty of Engineering here, young and handsome, Dr. Hendro. And we have the chairman of the chair of Language Center here, Dr. Deli Sabudu, and one of prominent professor here, Prof. Harris. We have here Professor Tanaumang. He's a senior professor here. And of course, we have also the vice deans from several faculties. We have Dr. Mercy, the one who is really interested in disaster. He is one of the experts of disaster in our university, and also the Vice Dean on Academic Affairs in Fakultas MIPA. And we have also the third Vice Dean on students and alumni from the same faculty, Ibu Dr. Nova Ogi. Here we have, and also we have here, Dr. Ron, the one I was informed that the one that you are mostly wanted, mostly looked for, Dr. Joy Kumat, for his articles on Manado tsunami models, where he has been here waiting for you. And also we have, sorry, I cannot mention one by one, but we have here also the head of the departments from Faculty of Social Science and Law, and also Faculty of Math, Natural Science are here. Everyone is here. And also we have from Tomohon, that represents the head of disasters, local disaster agency, Pak Kabit, and the two of them, both of them, Pak Kabit tolong berdiri, Pak Henry kalau salah. Yeah. Thank you for coming. Terima kasih sudah datang, Pak. And also we have students, and of course the most distinguished one, Prof. Harris and team. It is a privilege to have Prof. Harris and team coming and visiting this university. It's really a wonderful time for us. We feel that your coming is something that we have already waiting for a long time. As Dr. Mercy just told you a while ago down there in the first floor, that every time he presents in similar occasions and scientific forum on disaster, he keep on quoting your statement, who's next? Okay? So that underlines and emphasizes that you have been with us before you come here. And when, of course, we understand that this topic on disaster is rarely discussed here, but we believe by your enlightenment today, this will open our perspective, widen our perspective that something has to be done there in terms of preparedness, mitigation, on related to the geohazard itself. So this moment, I think, we would really impatient to hear, to listen to what you are going to share with us. And in this general lectures, taking the topic Bridges Over Troubled Waters, Experiment with Full Spectrum Geohazard Risk Reduction in Indonesia. We are really proud to host this, and we are really grateful to Fakultas MIPA for Professor Mokosuli, Dr. Mercy, and Dr. Armstrong for managing all the preparation and convince other scholars that we cannot miss this moment. this has to be here. And I think today we really enjoy. We hope really have the good times with you, and I hope you also have a good times with us, Prof. Harris. As you said, the trip to Unas Negeri Manado is quite challenging but interesting. All the ways here is actually this disastrous, risky. Yeah? It's very risky. All the lectures every day, they come and return home. They need to go down the street, and it's quite risky since the disaster might occur during the trip downtown to Manado. So again, so we have a potential collaboration, not only in terms of teaching, education with students, but also it is a very significant beginning to see that there are areas that is actually very crucial for our area, for our region, in terms of disaster risk reduction. And as I talked to Dr. Sorry, I forget the Whiten, okay, that he's a expert as mathematician, and just told me about learning about the pattern of disaster by looking at his data history, so to see the pattern of the disasters. So I think this would be a very nice and a very promising research collaboration in the future, and today might be the point of starting those patterns of collaboration, patterns of partnership between our university with the Brigham Young University, and also between lecturers from our researchers from our university with Prof. Harris and team. And I hope that this will not be the first visit, the last visit. They would be the first, which means there will be next, second, third, and so on. And we are very grateful if you feel this place is also your home. This is Dr. Mercy, is the leading expert in disaster here. So we hope that by Dr. Mercy connection, this will be a long time collaboration between our university and Prof. Harris, and also we're among researchers. So it seems, looking from the faces of the audience, they are cannot wait anymore to listen to your presentation, Prof. Harris. So on behalf of directors and thanking God for His blessing, I officially open these general lectures
on bridges over troubled waters, experiment with full spectrum geohazard risk reduction in Indonesia.
Thank you, Professor Maru, for your kind remarks and support. And now we are going to have a welcoming speech from the National Agency for Disaster Countermeasure, represented by Dr. Ingenieur Udrek SEMSC as the Director of Disaster Risk Mapping and Evaluation through the Zoom platform.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera bagi kita semua. Izinkan saya menyampaikan dalam bahasa Indonesia. Pertama-tama saya ucapkan terima kasih banyak kepada para pimpinan, para guru besar, Pak Rektor, Wakil Rektor dari Pak, dan juga rekan-rekan sahabat dari BPBD yang juga telah ikut membantu, dan apresiasi yang sangat besar juga kami sampaikan kepada rekan-rekan HAGI dari Pemwil Manado. Ini adalah sebuah kolaborasi yang cukup besar seperti yang kita lihat di dalam list di atas ini, di mana kita mendapatkan kesempatan yang sangat baik dari kedatangan Prof. Ron Haris yang akan berkunjung dan juga melakukan beberapa kegiatan di 4 lokasi. Dan di kedatangan pertama beliau sudah mengisi acara di Jakarta, termasuk di STMKG, dan lalu dilanjutkan pada kesempatan yang sekarang ini kita bisa bersama-sama nanti mendengarkan apa yang bisa disampaikan oleh Prof. Ron Haris. Beliau adalah seorang sahabat lama saya yang terus terang saya banyak sekali belajar kepada beliau, tidak hanya sekedar memahami beberapa hal terkait dengan bahaya geologi, tetapi juga hal-hal yang bersifat komitmen, tanggung jawab, dan upaya-upaya yang langsung kepada masyarakat agar memang tercipta ketangguhan di daerah. Dan ini rutinitas beliau yang setiap tahun selalu melaksanakan kegiatan ke Indonesia. Beliau sangat mencintai sekali Indonesia, di mana di dalam tahun ini kita kedatangan beliau itu untuk di Manado, setelah ini Halmahera, dan nanti ada di Sumatera Barat. Semoga nanti apa yang disampaikan oleh beliau itu bisa menjadi pembelajaran bagi kita, baik kita sebagai akademisi, ilmuwan, maupun dari adik-adik mahasiswa. Dan semoga seperti tadi yang disampaikan oleh Pak Wakil Rektor, ya kalau nggak salah ya, bahwa semoga nanti dari kegiatan ini bisa tercipta kerjasama yang lebih erat, baik dengan perguruan tinggi dan juga dari BPBD serta masyarakat nantinya juga, sehingga ini bukan pertemuan yang terakhir bagi Prof. Ron Haris, tetapi adalah sebuah langkah awal di mana kita bisa menjalin jejaring kerjasama yang lebih luas. Dan ini juga kegiatan ini menyebabkan saya juga bisa bertegur sapa dengan Bapak dan Ibu sekalian, juga rekan-rekan dari beberapa lembaga yang hadir turut membantu di kegiatan ini. Demikian yang bisa saya sampaikan. Semoga kita bisa mendapatkan banyak hal dari pembelajaran yang nanti akan disampaikan oleh Prof. Ron Haris. Demikian, Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi.
Thank you, Dr. Udrek, for your inspiring words and dedication to disaster preparedness in Indonesia. And now, we move to the main session, the general lecture by our distinguished speaker, Professor Ron A. Harris. This session will be moderated by Mr. Mercy Rampengan, Master of Applied Science, PhD. Please welcome them both on stage.
just short introduction because Ron seems to be really wants to speak as soon as possible. So untuk di sini saya lihat ada teman-teman BNPB. Terima kasih sudah datang. Ada juga yang lewat Zoom. Jadi Pak Ron Haris ini saya ingin sampaikan adalah seorang peneliti geologi khususnya kebencanaan yang sangat terkenal. Beliau menulis satu paper yang tadi saya sebut. I mentioned about your paper about who's next. Jadi ada paper beliau ditulis 2 tahun sebelum terjadi bencana di tsunami Aceh. Dalam papernya itu beliau sudah sampaikan hati-hati masyarakat di Sumatera bagian barat karena megatrust di Sumatera bagian barat itu sudah sekitar about 130 years until 150 years I think you mentioned in your paper who's next that the western part of the population, people in western part of Sumatra should be really aware about the probability that happen earthquake more than 8 scale Richter I think you mentioned in your paper. Jadi beliau sudah sampaikan bahwa akan ada kejadian besar dalam waktu dekat mungkin. Namun beliau menyesal ketika itu terjadi. Beliau tidak pernah datang kepada masyarakat untuk menyampaikan itu. Penyesalan beliau ini kemudian membuat beliau sering berkunjung ke Indonesia untuk meneliti banyak wilayah di Sumatera dan di Jawa, juga Nusa Tenggara, termasuk Bali. That's why when you visit here, a bit nervous for me, what kind of information that you want to share with us, because it will make us think more, not twice, but more than twice, about what kind of preparedness that we have to be prepared. Otherwise, we will miss, and lots of victims will happen. Like you said before, in western part of Sumatra, and you really deeply said about that one. You have no time to share the result of your research, and then ini menjadi masalah bagi kita semua. Seringkali hasil penelitian kita itu tidak terkomunikasikan dengan masyarakat. Ini yang saya sampaikan, teman-teman BPD sering mengundang saya, juga Pak Joy, itu untuk buat kajian-kajian kebencanaan, bicara dengan masyarakat. Karena mereka butuh informasi penelitian. So, we will create the bridge between the result of research and the community who actually become the first responder when a disaster happens. Okay, I think this is your peserta bisa scan QR code yang ada di layar untuk mengisi 5-10 menit. Survei kesiapsiagaan. Mohon bisa difoto untuk kemudian diisi. Mohon, karena ini juga butuh feedback kepada BNPB. So now it's my pleasure to invite Pak Ron to speak and also to explain about your research related, hopefully related to North Sulawesi, and the time is yours. The floor is yours. Please give a warm welcome for Pak Haris.
Thank you for taking the survey. We need your feedback. We need to understand what you know and what kind of issues that we should focus on. This survey helps us with that. It's our opportunity to listen to you before you listen to me. And then the results of the survey we use for helping us to make sure our presentation addresses the needs that you have. assuming everybody has this already, so I'm going to go on to my first slide. The title that I chose for this talk focuses on ways in which we can bridge a gap. The gap is one between what science understands and what the people who are in harm's way are ready for. There's a gap there, mainly because in academia we spend most of our time preparing materials that can be published in journals, and the people who are in harm's way don't have access to that information, either because they don't have access to the journal, or the publication is written in English, or the publication is very technical. And so there's a need, a very important need, for faculty and students from this university and other universities in Indonesia to make an effort to reach out to those who are actually in harm's way and help them understand what the risk is through communication and also risk reduction activities. So the second part of the title focuses on a new term that I've introduced called full spectrum disaster risk reduction. And as I give the talk, I think you'll understand more what I mean by full spectrum. For example, most of the academic community focuses on assessing the risk. And after publishing papers as to what the risk is, then there's no more follow-up in communicating the risk. So communication takes the risk to those who need it, and then actually having a strategy for what you can do to reduce the risk is the most important thing. Okay, so one of the most important aspects, one of the postulates that we use when we do our research is expressed by President Sukarno, Jangan Lupa Sejarah, and also James Hutton, the father of geology. Masa lalu adalah kunci untuk masa depan. So it's very important to dig into the past, not only figuratively, but literally, as you can see here. These two photographs show us searching for tsunami deposits. This is something that hasn't been done in northern Sulawesi, as far as I know, where you actually go to a place where a tsunami has deposited sand with marine organisms in it. Because it came onshore, it picked up the sand that was on the beach and moved it onshore and deposited it into lakes. We have, I think, 3 lakes that are close to the beach in northern Sulawesi that we should look at. This gives us an idea as to what's happened in the past, how often tsunamis have hit Manado. And also, it gives us an idea as to how large they are. I'd also like to introduce the rest of my team because I'd like to have them comment on this when it's time. Jared Whitehead, you want to stand up? Jared Whitehead is a professor of mathematics, but he's also a geophysicist, and he's learning a lot about geology as well. Jared is key in helping us to take these historical accounts and quantify them and use them as a way of trying to determine what the recurrence interval is of major earthquakes and tsunamis in this area of Indonesia. We'll give an example of what that is. So the historical records, like Jared calls people who lived before there were seismometers. So you can see this is a picture of Ambon after the 1998 earthquake. And it destroyed the whole city. And this wasn't the first time. It had destroyed Ambon 2 times before that. Even though the buildings were made out of wood, they still were destroyed. And so we need to understand that these historical accounts have gems of information that we can use to reconstruct what happened. We also take measurements like shear wave measurements because we had these historical accounts from Ambon. We went back to Ambon and we measured the velocity of shear waves in the city. And we found that the places where the shear waves moved slowly, then that's where the most damage was. And so now we have a way of checking that. There was also an earthquake in 2019 near Ambon, and we could go back and look and see if those same areas also were the most highly damaged, and they are. One good thing about Manado, is that most of the buildings are not built on the coastal plain. There's some that are. Most of them are built on the hills, which means that they're built closer to the bedrock. And seismic waves go through bedrock very fast. And so they're not amplified. They're not, and they don't last as long. The amplitude is low, and that's because of the fact that they're moving fast through the rocks. And so that's one good thing about Ambon, and also about this campus. This campus is built on volcanic rock. There's not a lot of soil between the buildings and the volcanic rock. So when you have an earthquake here, you have the advantage of being in a place where the seismic waves are going to move through this area very fast. When you slow a seismic wave down, then you increase its amplitude. And that probably will not happen here. Maybe by the lake, but most of this area is probably going to not be as affected by the ground shaking as those places that are built on the coastal plain, because they're built on unconsolidated material. So we've done these kind of surveys. We've done GPS surveys, which we use to measure the movement of the plates. In order for us to forecast an earthquake, we need to know 3 things. First of all, we need to know the velocity, or the velocity of the plates, but also we need to know how fast the pressure is accumulating along a fault zone. Second thing we need to know is the dimensions of the fault, or the fault zone. And the third thing we need to know is when was the last earthquake. If we know when the last earthquake was, then we can say, well, the pressure is building at 5 centimeters per year. And so since the last earthquake was 200 years ago, we can determine how much loading has occurred since that time. And then if we use the length of the potential fault zone, that'll give us a potential magnitude for this earthquake. So we would know 2 things. We would know where the earthquake is going to happen, and we would know how big it's going to be. But we don't know when. That is not knowable at this point. Everybody wants to know when, but we can't say when. And so that means that we have to think that it's coming immediately, and prepare for it. We call this during peacetime. When the ground starts to shake, peacetime is over. This is terror time, right? And so we need to do everything we can before the earthquake or tsunami happens. That takes a change in mindset, a different level of consciousness for us to essentially pay up front. We don't know exactly when this is going to happen, but we know it happened in the past several times and it's going to happen again. And so we've done these surveys all over Indonesia except for here. And I appreciate Gideon's mentioning that I've been here even though this is the first time I've been here. Thank you. Because this has always been on the agenda to come to Manado and to come to northern Sulawesi. I've been to Palu. I've been to Belakumba in the southern part, Makassar, but never to the northern arm. And I always thought that this would probably be the most important place of all of the other places that I've been to go to. Because you go from the ocean where there's a subduction zone offshore, you drive up this beautiful road to get to your campus, and there's active volcanoes all over. You have active faults, active volcanoes, and a big deep ocean next to you that can create a tsunami. And so you have volcanic hazards, tsunami hazards, earthquake hazards, and then you have floods, and then you have landslides. And so maybe the most dangerous place to live in Indonesia is Manado. Yeah? Does that make you feel good? It can be a problem if you ignore it. It can be a problem if you ignore it, right? But if you embrace it and you prepare, then you can enjoy the beauty of the volcanoes and the beauty of the ocean. And know that you can't completely reduce the hazard, but you can at least in the process, by coming together as one group, doing full spectrum disaster mitigation, you can mitigate, you can reduce the risk. Okay? All right. So what is a seismic gap? So I'm calling this speaking tour the Seismic Gap Speaking Tour. And so what is a seismic gap? Well, let me show you some very simple illustrations of what a seismic gap is. Let's see. So I need to click. Oh, there we go. Okay. So this is a very simple illustration. This is a plastic cutting board and some bubble wrap. The bubble wrap represents the lower plate in a subduction zone. The plastic cutting board represents Manado and the northern peninsula of Sulawesi. That right there was a large seismic gap. There were no earthquakes while this thing was going like this. Absolutely no earthquakes. Are very small, and then all of a sudden, all of that energy was released. Let me try it again. Okay. So ini gempa bumi kecil. gempa bumi kecil. And mungkin magnitude 7, magnitude 4. Okay? And then tidak ada gempa bumi. Oh, mega thrust earthquake. Yeah. That's what we're expecting in the northern peninsula of Sulawesi, is a mega thrust earthquake. And where are we in this? We call this the earthquake cycle. After that big event, Tidataku, because all of the energy was released. So after the event, it's very safe. The safest place for you to live in Indonesia? Banda Aceh. Yeah? Sudah megathrust earthquake. Yeah. But maybe the most dangerous place for you to live is in a seismic gap. And Manado is one of the most dangerous seismic gaps. Yeah. This is scary one. Yeah. So this is my dog right here. His name is her name is Gaia. I called her Gaia because G stands for the great, I stands for the Indonesian, and A stands for archipelago. So she's named after the great Indonesian archipelago. It's also the name of a Greek goddess, so either way, she's been named. But she came to see the megathrust earthquake, right? All right. Okay, what happens if this megathrust earthquake happens underwater? Okay, so here's Manado right here, and the northern peninsula of Sulawesi. Here's the Celebes Sea plate right here going down, and this is the Eurasian plate right here. You'll see the same thing happen. The lower plate is pulling the upper plate with it, and then eventually it overcomes friction, and it displaces a huge amount of water. That's what causes tsunamis due to megathrust earthquakes. And then the destructive power of that earthquake moves way away from the epicenter and affects places that are hundreds of kilometers away, places that didn't feel any shaking. Okay. So here's the compilation of all of our historical work done on tsunamis and earthquakes. The red here are major damaging earthquakes that have happened in the Maluku region, Malacca region, from 1629 until, you can see over here, Tidak ada gempa bumi di sini. Dua saja. This is a seismic gap. It's been a seismic gap since 1899. And the strange thing about this is that the historical accounts are not near as reliable as the seismic data we get from seismometers. And so we should have a lot more information in that box because we've had seismometers. But there hasn't been any earthquakes, so we know that there hasn't been earthquakes in there. And because it's hard to rely on historical accounts, there's probably a lot more damaging events that happened before the gap that makes the gap even more dangerous. Down here you can see this is the number of earthquakes. So one line is one earthquake, another line is two in each of these years. And then the blue lines are tsunamis. And you can see that there's been quite a lot of tsunamis that have happened over the past. And this is not quite as empty as this box, But some of these tsunamis, we don't know where they came from. And so that's been a very important work that my colleague Jared Whitehead has done. So Jared, could you, or just a second, let me show this. This is going to show you the history of earthquakes in eastern Indonesia. The reason we're studying eastern Indonesia is because no one else does. Western Indonesia dominates, gets almost all the attention, right? Sumatra, Java. Only parts of Indonesia are Sumatra and Java. Maybe Bali. Yeah, yeah. And so we need to work in eastern Indonesia. All right, so this is the history of earthquakes. So the blue ones are earthquakes that happened from the 1600s to the 1800s. Or I made a mistake and put the 1852 event right up there. But these are all during the 17th century. And then these are during the 18th century and 19th century. So we have 1845, that right there would have affected Ambon. Okay? And the 1846. And then we have this huge one over here, 1852. We have another one, 1855, and another one, 1857. This is what we call an earthquake storm. Because you have one earthquake and it transfers a lot of the pressure to other fault zones and causes that cycle that I was talking about to change. In some places it will reduce the stress, lengthening the cycle. In other places it will increase the stress, which shortens the cycle. In this case, many of those fault zones probably were mid-cycle, but because there was an earthquake near there and added stress to it, it happened earlier than normal. So usually when you have a big megathrust event, you also have these secondary events that occur. But since this time, nothing has happened. 57, 66, 76. This is the last big earthquake in 1898 that happened in Ambon, the one that showed you, that had all the destruction. Okay, and then there was this 7.4 in Sulawesi. We have the 7.8 in 1992 in Flores. We have the 7.9 in 1996. And then we have, let's see, the ones in green are the ones in the 21st century. So this is the Palu earthquake that happened in 2018. We've had other ones happening around. This right here. This is what concerns me. No earthquakes for over 150 years, and then all of a sudden you get a small one. A lot of times this means, yes, yeah, right down the middle. Yeah, it's a collision zone between two accretionary wedges. So this 7.5, is it a foreshock? Like, remember the cutting board? It started to make earthquakes right before it finally gave? We don't know. But there's another one, 7.1 in 2019. So we can now determine, based on the historical accounts, how much pressure has accumulated along these fault zones. For example, right here, this area has a plate motion of 11 centimeters a year, which is one of the highest plate motions on the planet. And so in the amount of time since these last events, we have 17 meters of slip. And so Manado has been pushed 17 meters to the south since 150 years ago. And eventually it will recover. The whole northern peninsula of Sulawesi will jump to the north around the speed of sound 17 meters. So if you can imagine, the position of Manado will be 17 meters further to the north than it is now. And it will probably happen over a length at least to here. That entire length there, which would mean it has the potential of being an 8.7 event. And you can also see this tells you how much strain is accumulated in other sections. So 10 meters in this area, 15 meters in the Timor Trough, and the Java Trench, 30 meters of strain. Java will jump to the south 30 meters. Everybody's surveys will be off by 30 meters. That's what a megathrust earthquake does. Okay, Jared, you want to talk about this? So the question, I'll let Jared.
Thank you, So this is, in particular, this is looking at a historical earthquake that happened in the Banda Sea in 1852. And in this case, if you look at this figure on the left, it's labeled as the prior. This is showing us the subduction zone in the Banda Sea. So you can see the bright yellow color is where the around 20 kilometers deep in the subduction zone. And what you can see as it's a little harder to see from a distance, but you can kind of see these red dots along the islands. And each one of those red dots corresponds to a location in 1852 where a tsunami was observed from a massive earthquake. And what we did is we went through, as Ron was describing, we looked at the historical records, and each one of those red dots had a description of the impact of the tsunami. And what our job, our task is to take those descriptions, these historical anecdotal accounts that would talk about a tsunami wave going over the top of the house or displacing boats, and we wanted to interpret that and come up with a definitive way of determining the location of the earthquake that caused that and the magnitude of the earthquake that caused that. So what we did is we built up a statistical method, a model, that allowed us to do that. And that's what you see on the right plot, which is labeled as the posterior samples. So what we did as our hypothesis is we said that the earthquake could have originated anywhere along this subduction zone, the entire fault, what you see on the left. And using the data that we collected, the observational data from the historical records, it indicated that the actual source of the earthquake had a centroid or an epicenter located most likely in the plot that you see on the right. And we also determined that the earthquake source was most likely over magnitude 8.5 for that event in 1852. We've done this for similar historical records, and the goal is that we can not only understand what happened in the past, but we can also understand a little bit better idea of the uncertainty. Because we have difficulty with seismology today, even when we have really good instrumentation. Looking in the past is critical, but we also need to understand how uncertain our estimates are. And that's part of what this statistical approach has allowed us to do. It's also given us an opportunity. What you see on the right is a compilation taken from several thousand different simulations of potential tsunamis. And so we now have the capability of running several thousands, even tens of thousands of tsunami simulations and looking at the impact that those potential tsunami hazards can have in different coastal regions, such as northern Sulawesi, and that's what we're hoping to do next.
So this is depends upon having at least enough historical records that you can guide the position of each new point. So if you can imagine, if I say this wrong, correct me, but you can imagine you give it a prior and then using a Bayesian analysis, the computer drops a point somewhere in that initial space, and that point will move in the direction of higher probability. Is that correct? Okay. And so the point where it starts is random, but where it ends up is not. And that's based on the fact that we have at least 5 or 6 constraints that give us wave height, also the amount of time between the earthquake and the tsunami. And also we have the height of the tsunamis. And these can also help us to understand the magnitude of the event, not just the location. And the magnitude and the locations are fairly well constrained with low uncertainties. Unfortunately, the tsunamis that have hit the northern arm of Sulawesi, we don't have very many historical records for. And we don't have as much coverage. Not enough spices in Maluku. Yeah. And so we're hoping by doing more historical sleuthing, we can come up with more data. But the model that Jared did for northern part of Sulawesi didn't work, right? Yeah. Okay. So let me tell you about another seismic gap. So when we started this research back in the 1990s, putting all these historical accounts together, we found that there was a rich a collection of historical accounts along the western edge of Sumatra. And you can see the dates there, 1861, 1795 to 1799, we don't know exactly which, 1833, and so on. And so this subduction zone was creating huge earthquakes, megathrust earthquakes. But in the northern part, there was no evidence from the historical accounts that there were any big megathrust earthquakes. And we didn't know if that was because of lack of observation by the Dutch, or if it was because the subduction zone was not sticking. Instead of having bubble wrap go down, it was just a piece of paper, so it never did stick. Or if it was accumulating strain. So those were our 3 options. Well, the most dangerous of those 3 options is that it's stuck, like the cutting board against the bubble wrap. And so that's the one we went with. We're like, well, of the 3, we would much rather be wrong about the other 2 than the first one. And so we outlined what we thought was a seismic gap. In fact, our seismic gap was initially not as big as that one, because that one right there corresponds to this earthquake, the 9.2 second or third largest earthquake ever recorded, and the largest tsunami in history. So seismic gaps, we have another one, at least down there. After that, we had a whole cluster of earthquakes, just like what happened in the Moluccas back in the 1850s. So right next to the 2004 event, we had one in 2005, which was an 8.7, which is not a small event. And then we had a tsunami event in Java in 2006. We had an earthquake in Java in 2006. We had an earthquake underneath Jakarta in 2007. Then another earthquake, 2007, in the northern part of that second gap. And then these earthquakes are near Padang. We had a 100-year eruption of Mount Merapi. And then we had these 2 earthquakes right here, both on April 11th, 8.6 and 8.2. The largest earthquakes that have ever happened on a subducting plate. That's an earthquake storm we haven't seen for a long time. And my message to you is it's not over yet. We're still in the midst of it. There had been a 50-year period of time when the entire planet had not had an earthquake greater than 8.5. There was a bunch of earthquakes in Alaska and in Russia and stuff, and then 50 years without anything greater than an 8.5. And then we had the Sumatra event. And now we have 1, 2, 3, 4, 5, 6 earthquakes over 8.5 in only 15 years. So Indonesia's teaching us a lot about how plate boundaries work and how they relate to earthquakes. So this is showing you all of the major fault zones in Indonesia. And this is how much energy has been accumulated and what the earthquake size is going to be. We call this now casting. It's what meteorologists do. They now cast based on historical data that they have. They can cast now whether it's going to rain or not. Well, these are nowcasts for earthquakes. So if this earthquake happened right now and the entire section ruptured, it could be a magnitude 9. It has 35 meters of strain accumulated. This one in the Timor Trough, 8.4. This one in Papua would be 8.8. And this one where you guys are, 8.7. We don't know exactly how many years it's been, so there's a question mark with 165. It could be even longer, which means it would be a larger event. That's what you need to prepare for. An 8.7 earthquake and the associated tsunami that's going to hit. Again, when is the wrong question? What is the right question? Are we ready? Do you think we are? Good. That's a good place to be. At least you're ready. Yeah. Okay. So one of the ways we've tried to extend the historical record back further, since we only have 400 years, I shouldn't say only, that's a long time, is to look at the geological records. For example, this is in Java. We found 2 tsunami deposits, one that gave us an age of 500 years, another one that gave us an age of 1,000 years. Where is Hanif? Hanif, stand up. Hanif was one of my grad students, and this is his work. He went all over. This especially was great work by Hanif. A lot of those little deposits of tsunami sand are very hard to preserve, especially when people are farming every single bit of land that there is. They destroy those tsunami deposits shortly after they're deposited. So we, with the help of Hanif, we discovered a new type of tsunami deposit called an imbricated beach rock deposit. So what Hanif did is he went to Google Earth, he looked at all the beaches in Indonesia. Think of how long that would take, right? The whole time thinking, oh, that would be a fun one to go to, that would be a fun one to go to. And then he said, I think we can see these imbricated beach rocks at all of these different beaches. So this was a very fun research project. We went from beach to beach to beach to beach. This one is in Lombok. Look at the size of these blocks of rock right here. And look at this, the smaller ones have gone way back up here. When we walked out here, we saw blocks of rock, like that one right there, that had gone all the way over the berm. And we thought, well, is this storm waves or is this tsunamis? So we had drones, and so we did a drone survey of all of these deposits in Java and in Lombok. And then we went back a year later after the storms and did another survey. And then a year later after the storms again and did another survey, and none of the blocks had moved. So then we thought, well, if they're storms, then they should be different ages, like a whole variety of ages, because each year you would be adding a block or taking a block away. So we got age analysis. We did an age analysis of carbon-14 on the shells, and the ages clustered. They clustered at 500 years, and they clustered at 1,000. And some 1,500 years, 1,700. So what we could see is a cycle, tsunami megathrust cycle on the Java Trench, about every 500 years. Guess how long it's been since the last one? It was 500 years ago. Now, we don't know when, but we know when the cycle, the earthquake cycle, is reaching full cycle. And this one is reaching full cycle. Think of the destruction, damage that's going to happen in Java. When a Sumatra-sized tsunami comes, there's so many more people that live on the coast of Java. So we've made tsunami models. Jared is an expert in tsunami models. And you also have your own expert right over here in tsunami models. Forgot your name. Joy, that's right. Joy, stand up. Come on, we need to give you an applause. Joy's done a tsunami model for Manado. And Bintang in the south. And you've had volcanic rocks pouring out of the crack down here. the last eruption, which was in 1988, the lava is at risk of failure. So we made a tsunami model. That's the tsunami. Notice it goes all the way over that island. These are the tsunami heights in meters. 76 meters. So it's not just tsunamis caused by earthquakes, but also by collapsing. Okay, so there was a reference to this paper that I published in 2002 with my Indonesian grad student, Carlos Prasadyati. And we said that the most dangerous seismic gaps in Indonesia are in populated areas of Western Sumatra and so on. We said that if this was released suddenly, it would produce an 8.5 earthquake. So 2 years after this article was written, and I can't tell you how difficult it was for me to deal with that, because we had made a forecast, but we didn't do anything else. We made a forecast only. If we would have really believed our own forecast, we would have gone to Sumatra, village to village to village, and talked to them about what to do when the ground shakes. When the ground shakes, there might be a tsunami, and they've got to go to high ground. And they've got to go immediately. They only have probably 20 minutes to get to high ground. And there's lots of high ground in Sumatra. But we didn't do that. We thought someone else would take our paper and, with all of this magical knowledge, go to these villages and explain this to them, and the villagers would be open to this and know what to do. But it didn't happen. So this is the paper by Joey. And the impact that this will happen in Manado City. So what we need to do now that Joey's shown us what's going to happen, we need to take it seriously, and we need to go to the places that are in his inundation map. And we not only need to show them the map, but we need to talk to them about what they do and what they don't do. And the most important thing they don't do is wait around. Because that's what happened in Sumatra. They had 14 minutes of shaking. In Papa last minute of rasa, if I said that right. And then they just didn't do anything. They didn't know there was a connection between the earthquake and a tsunami, because it had been hundreds of years since there had been a tsunami there. So I've shown you that. I want to talk to you about the Mokum people. They live in the islands off the coast of Bencana. This is also where the epicenter for the 2004 earthquake was right there. So these people were the closest to the epicenter and also were affected by some of the highest tsunami waves. And yet, they had the highest survival of any other place during that tsunami. So figure that. The least knowledge, no assessment, and almost complete survival. Why? What secret did they have that the rest of us don't have? So the secret is they had a story about a sea monster named Laboon. You would know that Laboon was approaching because the ground would shake. And when the ground would shake, you had to immediately right? So you also get other people involved, not just the community leaders, but the religious leaders as well, okay? And the mosques, at least in this village, have these large drums, like a call to attention. And so what they did is on the second drill, they got everybody to come, and they rang the drums. The drum music was all over the valley, and they practiced this evacuation drill. Within a few days of this second drill, the call came down on the radio that the dam was breaking. The water had got all the way to the top, and it was now spilling over. And so they instigated the drum, and they also started to, they had a siren as well that they had. They started to get people to evacuate. So that's the before and that's the after right there. It took 12 minutes for the water, that was right here. This is the landslide right here. Look how it came down, washed up on this side, come over here, washed up on that side, washed up on that side. The wave was over 30 meters high. It came down and it destroyed 428 homes, washed out into the ocean. The only home that survived was this one right here, because it got stuck in the trees on its way out. You can see how, this is me standing right here, and you can see how high waves got as they went down the street. 23 deaths. So this was never reported in the newspaper. It was never reported on the television, as far as I know. But it should have been, because this is what we're about. Only 3 people died, and they had only 12 minutes to evacuate. That's what we should celebrate when that happens. The second one I want to talk about could be even more applicable to you. This was the eruption of Kilut volcano. And the eruption happened only 2 hours after the residents were advised to evacuate. So they were on yellow alert, and then it went to red alert, and there were 2 undergraduate students from Universitas Pembangunan Nasional who for their senior thesis, went to their homes near Kelut and studied the volcano and then did an evacuation drill. Because of those 2 undergraduate geology students, when it went to red, everybody knew what.
Let you know that during the earthquake 1845 in Sulawesi, the Fort Amsterdam, built by Dutch, was broken up in Manado, and also in Minas Selatan, another fort also, and that's one of the big earthquake in North Sulawesi. Like in Tomohon, just 7 houses just standing on the ground. Other than others just broken down. And also, North Sulawesi has one of the deadliest on earth, Au.
So they can't get trucks up the road?
No, because the villages that's on the volcano, even the that's the
So you hope that you can get boats there.
so many boats.
How many people live on the
That will also produce the highest.
That's a problem. We're smarter than the volcano.
Tsunami volcano corruption, including the
Yeah. Huge problem.
yes.
So you need to install tidal gauges. You need to have tidal gauges. And
For
so
give
it
a
will
warning.
warn, yeah. In 2018, not corrupted, and they didn't have any tidal gauges. No warning.
To the minds. Sometimes
Terima kasih atas kesempatan yang diberikan. I'm sorry, my English not so good, so maybe campur-campur. Perkenalkan, saya Farli Momor dari jurusan Fisika. Ketika itu terjadi, bagaimana kita yang dalam kondisi seperti ini dan ketiadaan informasi mitigasi bencana, mungkin dimulai dari kira-kira dari gedung.
Tadi saya sudah coba bantu terjemahkan, tapi Pak Ron bilang, coba kamu aja yang jawab, kata dia gitu. Jadi ya tadi kita juga sama-sama mendengarkan bahwa kita tahu seberapa besar kemungkinan terjadinya, kemudian kita tahu di mana, tapi kita nggak tahu kapan, sesuai dengan pertanyaan tadi. Nah, saya dan salah satu hal yang ingin ditekankan Pak Ron adalah bukan seberapa besar yang bisa kita lakukan, tapi apa yang bisa kita lakukan. Jadi setuju banget sama pertanyaannya bahwa gimana kita pakai case sekarang aja gitu ya, kita udah di lantai 3 gitu. Terus biasanya mungkin ini juga sebagai masukan, biasanya kalau untuk kesadaran kebencanaan bersama, di awal mungkin ada semacam kayak safety thing dulu.
Group focus on the lake, and another group focus on a certain neighborhood in Manado. Then you have focused group working on these problems, drawing from their expertise in other areas. I think that should be an academic course.
We need your support, Pak. So I mean, in here we have Faculty of Maths, Natural Sciences, and Earthiness, so Geoscience. So it means, and the new one, actually that the new one, we need like collaboration because lack of resources in terms of researcher as well. Because just establish that specific study program. So I mean, maybe we can collaborate later on with your university or foundation because we can explore lots of hazards in here and such hazards actually not really separate with other hazards, but possibly coming together. So I mean, this is not only can be established by the university, but also the local government,
Right.
provincial level, and also district level, and also university from outside that actually already established or know lots
Yeah.
about our regions.
Right.
So I mean, our rector, I think, also vice rector here, will be really happy to have that one.
Yeah.
And the head of research center also mentioned several times to me that he wants to actually establish the center of disaster studies in here. I mean, it's a good chance for us actually.
So I agree that you need to bring in a lot of people, but it's the academic community that can spark it, that can get it started. And if students were working on this for a class, then the students know they have to report. They did. Get a grade. That's huge motivation. Students want to get good grades. And if they get involved in a hands-on experience, assessing the hazards of a volcano, assessing the hazards of a tsunami in a certain area.
We already written down document about risk assessment in several area of North Sulawesi. Collaborate with the disaster agencies, local disaster agencies, and actually in terms of how to make a plan of the preparedness document, it challenge actually. Don't need to elaborate with others.
Yeah. So I just want to make this other statement. For me, the way I got into this is I absolutely love geology and geophysics. It's my passion. And you have your passion for your topic. But the passion is not enough unless it overlaps with the needs of others. When your passion is not only giving you a lot of satisfaction, but helps other people as well, then you're truly happy. That's my challenge to you. Is to use your passion, find a way to use what you love to do the most to help other people in this situation. And I know you'll find something.
Question also? It's okay?
Yeah.
Oke, ada yang mau bertanya? Mahasiswa di belakang? Sorry. Oh. Silakan. Ada paling mahasiswa kok.
Izin pakai bahasa Indonesia. Pak, merci boleh slide. Terima kasih atas penjelasan dari Profesor Haris yang begitu lengkap. Nama saya Roxy Rumondor. Kalian saya di bidang geofisik. Saya tertarik dari penjelasan dari Prof Haris ini mengenai tanah longsor, landslide. Nah, sejauh yang saya ketahui untuk geofisika, dari contoh Prof Haris tadi itu sepertinya menonjolkan metode PSHA, Probabilistic Seismic Hazard Analysis. Koreksi jika saya salah. Nah, apakah Probabilistic Seismic Hazard Analysis ini bisa diterapkan untuk landslide? Karena di Sulawesi Utara selama 2 bulan terakhir, bahkan sampai 2 hari yang lalu, itu di jalan highway Tomohon Manado, Tanggari juga, itu banyak sekali landslide begitu. Apakah bisa diterapkan untuk PSHA ini di landslide agar bisa meminimalisir tadi kerugian korban, kerugian secara ekonomi, traffic dan lain-lain. Terima kasih.
So you're asking about landslides.
Related to the use of PSHA methods.
Use of
Probabilistic Seismic Hazard Analysis.
Oh.
Is it possible to apply for the landslides hazards?
Is it possible to do what?
To apply. Yeah.
To the landslides
Yes.
across the roads. Yeah, that's a hard one. It goes back to the engineering. Initially, these roads were built with a certain engineering in terms of slopes stability, and that can change. When banyak hujan, then the slope stability decreases. And so the only thing you can do is to re-engineer the road cuts. And that's not a trivial task. But if there's places where it recurs constantly and constantly, then you have to go in and you have to regrade the road cut. So that'd be something your engineers, do you have engineers here? Yeah,
Yeah, we have faculty of
yeah,
engineer.
that they'd be really good at.
Demikian Ner Rumondor. Thank you. Ada pertanyaan lagi? Silakan Ner.
For opportunity to me. Jefferson Poli from Geophysics program study. Currently serving as coordinator of program study. I'm interested the what's the state from this rural hazard. This assessment does not save lives unless the risk is communicated effectively to people, and the risk natural disaster in the right place to be written to the people. My question: Manado State University, mostly of us related to education, those from deep educational campus. So we are teacher, we are lecturer and the student, and mostly of our graduates is and their student will become the teacher. So we are mostly related to student or member of school. My question: what the effectively steps or tips so we can share to people or member of school, teacher, student, principal in school to reduce the natural hazard. Besides the training, socialization, extracurricular, can we include the natural hazard matters in curriculum? This is my question.
So let me see if
Thank
I
you.
understand. So you're saying how do we get it from the assessment stage to the planning stage with, did you say with the government or? Yeah, I don't know if I understood your question.
I agree with your state about natural risk is assessment is not safe unless that risk is communicated effectively to
Yeah.
people.
Yeah.
So related to us as educational campus, so our student will become mostly of them is become teacher.
Yeah,
So what the step effectively for them for us
yeah.
to share with member of school about disaster and risk reduction disaster.
Yeah,
Thank
thank you. I think I understand. I think the most important thing is to make it simple. So, like I showed you with the cutting board and the bubble wrap, that helps people understand in a very visual way what a seismic gap is and why it's important. And so I think when you approach the people that are in harm's way, you first have to communicate that you're there to help them. You're not there to get anything from them. And then I think it's really important to focus on one hazard, like that affects that community the most. Like if it's landslides, or if it's because they live on the coast and they're vulnerable to a tsunami, or if they live next to a volcano. Focus on that and say, okay, this is what's happened in the past, and so it's going to happen again. When it happens again, what are you going to do? That's how I would approach it.
Thank you, Prof.
Yeah.
Ada pertanyaan lagi? Ini dosen baru.
These are great
He's a
questions.
student, high school.
school.
Okay. You. Hey.
Oh, hi everyone. It's my myself first. I'm first year Norris, and I'm still a student. Still 13 years old, and still 7th grade. And I'm interested to ask. So I live in a coastal area in Manado, just about 2 kilometers from the sea, and I'm worried that my house will be beaten by the waves, tsunamis. And when can you predict that Manado is going to be hit by a tsunami again?
Tita Bisa, we cannot, we don't know.
predict.
We try to avoid the word predict because it implies that we have certainty. We don't know. But when the ground starts to shake,
But is there going to be a percentage of it?
what's that?
Is there going to be a percentage of it happening?
No,
No.
no. I'm sorry.
Right.
There's too much uncertainty to make any kind of statement about percent, of this going on. Like, okay,
Because
I'm sorry for the bad news.
no worries, I've just been through.
That's why we get ready now, so we don't have to worry about when.
Silakan, Ci.
Well, thank you very much. I think probably this is a shallow question, but I'm eager to know your answer about this question. Based on recent geological and seismological studies, what is the estimated probability and potential impact of a megathrust earthquake originating from the North Sulawesi subduction zone within the next few decades? And probably I would like to ask about your perspective or opinion. Should the government consider relocating critical public services and densely populated settlements away from high-risk zones, especially in North Sulawesi? Thank you. That's all my question.
So let me see if I got the question right. You asked what the probability is of a megathrust earthquake?
But yeah, probability, or probably but the impact of this.
Again, we can't say what the probability of it is. We can only say what it's going to be if it happens now. And there's still a lot of uncertainty with that. So we can say that it would probably be a magnitude 8.5 to 8.7 earthquake. And it would probably be in the northern part of Sulawesi. And we can make a model like Joey did that shows what would likely happen. But we don't know where in the earthquake cycle the fault zone is. And we don't know if it's going to be another 100 years or it's going to be today. So the plus or minus is really high. The important thing to note, though, is that there's already enough energy to produce a magnitude 8.7. And so that's the most important number. We don't know when. I'm sorry, we just don't know when. I know everybody wants to know when, but it's not possible.
We are so worried about that.
Yeah.
Because
There is a paper in 2012 talk about probability of tsunami of Sulawesi in the model. Megathrust of North Sulawesi and megathrust shape. So, but not from Indonesia. The writers from outside Indonesia, I forget his name. It's a paper.
So let me tell you what you would need to know in order to do a probability. You would need to have a record of several events in the past to see if there's a cyclicity, to see if it's periodic. And even then, there's a lot of uncertainty. We only have a couple of events. We don't know even exactly where they were. We can estimate where they happened by how much damage there was, but we don't have a good enough database to make any kind of probability statement. And those who do, I think, are doing a disservice to the science, because they're implying that there's more certainty than there really is.
Ada pertanyaan lagi? Oh, Prof.
Thank you. Speaker Professor Haris. Actually, I'm interested in your idea, talking about spatial community, to focus on spatial disaster, spatial hazard, instead of tsunami, volcanoes, or landslide. In this case, I agree with you. So the solution is we have to work together, collaborate with some university and local government in North Sulawesi to do like your idea, to do some community handle, for example, in each area or each kabupaten kota district, make special community to handle special hazard, special and disaster. Sorry, hazard. So again, I agree with this idea. So we have to think about that, Mr. Mercy, the expert in this university who much handle about this study. Again, another question related to this point, that as my friend said before, that our university handle, or some faculty, some department handle about schools, school, teacher, and students. So the question, like just told just now, that it's better we have to suggest to our government how to socialize this program in the school.
Yeah.
Maybe we can make insert this in a special curriculum in some school, whether in middle high school or senior high school. It is another kind how to socialize this program, this hazard in our local government or our area, North Sulawesi. Thank you.
Terima kasih, Prof.
Thank you. I think that's a very important thing to do, is to get a local community level committee together with diverse interests and talents that can bring to bear on these questions. And I don't know how to motivate people to do that. Some people do it on their own, but it's a very difficult thing for people to take on extra. So I don't have an answer for how to get it started, although I think the academic community has a unique angle on that. And I think if you have committees within the university, and the people working on the committees are given credit for that. So, Gideon, you need to give your faculty and your students credit for working on natural hazard stuff. That's going to motivate them, right? You need to find a way to break out of the mold And then you talk about education in the schools. I know that the younger that the children are exposed to this, the more they understand when it happens. And so it's not something new. It should happen in the home and family, but a lot of times there's a lack of education there. But the schools have to adopt a natural hazard risk reduction program. And it has to be in every grade, not just one grade. It has to be in every grade so it can build on itself. Yeah, I don't know. Japan is one of the places that does this. They incorporate natural hazard risk reduction into every single grade. And so when they had a big tsunami, only 20,000 people died. When Indonesia had a big tsunami, 200,000 people died. And the difference, I think, was elementary education.
Aaron, thank you.
Okay, thank you very much.
Maron, we have like in here in Indonesia Satuan Pendidikan Aman Bencana, SPAB. In North Sulawesi, just in the initial step to the Satuan Pendidikan. So in schools. Dan Prof, mereka sudah punya kurikulum sebenarnya. Cuma di Sulawesi Utara sendiri, SK Gubernur Satuan Pendidikan kita bisa masuk situ. Still have time for asking question?
Yeah.
Ada lagi yang mau bertanya? Oh, silakan. Sudah pegang pimpinan ini.
Thank you. Merci. As it is predicted, his general lecture is really enlightening for us, and his last conversation inspired us to some ideas. I'm thinking of nationally we have every year we have a grant, national grant, recommend the science degree. One of the scheme of grant is consortium. So what I'm thinking is that I think we have Dr. Rampengan here. We have the chair of the research institute in his university. I'm thinking of, I think after this, Dr. Mercy and Dr. Armstrong need to discuss of having a consortium on disasters mitigation studies or policies. And then you also inspire us that after this, maybe we need to think, seeing the urgency of mitigating or anticipating all of this disaster in reducing the potential impact of disasters. I think we need to we need Dr. Rampengan to help us to have new subjects in this university that is compulsory for all of the departments to have a kind of disaster mitigations, mata kuliah kebencanaan, begitu, that become, whether it is optional or compulsory, mata kuliah pilihan atau wajib di semua prodi, dan itu juga, that will be one of the unique characteristic of our university. I think kampus yang lain, ada university they haven't had a particular subject on disaster that or a compulsory subject, or one university is mostly focusing on the disaster reduction or mitigation. So I think I asked Dr. Mercy to be the team for that subject. So all the description subjects will be given, of course, in consultations with Prof. Harris and Prof. Whitehead. And then will be one of our attempt to implement the national program on campus berdampak, right? So that will be our characteristic, or one of the characteristics that we offer the government, also to society, that we take part, participate in mitigation, and as Professor Sumual has already suggested that we might form or design how to the program, how to educate, maybe taking the models, Japanese model, educate children starting from elementary level, anticipate the risk of disasters. So we can be, I think we can start to be a pioneer for that. So what I'm asking from you is that is it possible later our chair of the research institute and Dr. Mercy and the team that later to enhance to widen these collaborations to be more concrete in terms of consortium for consortium for research later. And we have here the vice directors on collaborations, and she might follow up this meeting with more concrete programs. That's what we expect.
Yeah, I
Thank you.
think that's a huge step forward. Can I just add something to that? I think as long as there's a practical aspect to this, where students actually interact with the people who are in harm's way, and they go to the volcano, they go to the coastline if they haven't, and they see how far the inundation goes. There has to be a practical aspect to the education. It can't just be talk, because that's all that it is now, is talk. It has to be a practical application in order for it to work. Meetings like this happen all the time. And after the meeting, nothing happens. And mostly that's because there isn't a commitment to actually the aspect. You have to take a field trip, it changes everything.
Okay, any question? Ada?
Two, one over here, there, three.
From BNPB,
Oh,
Disaster Agency, from Minahasa. After
TV?
Sir, my name is Osvaldo Jericho and I'm majoring in geography. My question is, given Indonesia's unique geologically settings, what are the most critical challenges in implementing the full spectrum geohazard risk reduction strategy in Indonesia? Thank you.
So what is the major challenge?
Yes.
Is that what you said? Wow, that's a great question. Depends on which day. Depends on which volcano's erupting. Depends on which earthquake has happened. But the biggest challenge is to get people to walk from one side of the university to the other and start working together. Let me give you an example. We were working on these historical accounts, and I knew that there was probably a better way than what we were doing that was more quantitative. So I sent a message to the head of the math department, and I said, I need help from the math department. This is what I'm trying to do. I'm trying to use historical accounts to determine where major events were in the past so we can protect people in the future. And Jared responded to my email and said, hey, that sounds like a good thing to do. And that has benefited our research so much. So you have to actually invite people to come. Otherwise, it's not full spectrum. And you have to make sure that the people understand that their expertise is valuable and useful. Did that answer your question?
Sir.
Okay, thank you.
Thank
I
you.
wasn't sure you were going to say yes. Yeah.
Oke, Pak Joy, BPBD Minahasa. So we have from local disaster agency
Local
from
BPBD.
Minahasa, Minahasa Utara, Tomohon. Oh, Kota Manado. Ini head of BPBD Kota Manado.
Ya, terima kasih atas kesempatan yang diberikan. Nama saya Joy Keundang dari BPBD Kabupaten Minahasa. Ya, mohon maaf, Prof, I cannot speak English very well. So,
You're doing great.
Bahasa Indonesia. Ya. Saya ingin memberitahukan bahwa Kabupaten Minahasa, BPBD Kabupaten Minahasa sementara mempersiapkan diri dan tahun depan akan membuat suatu kegiatan yang namanya penyusunan rencana kontingensi gempa bumi dan tsunami. Rencana kontingensi ini adalah suatu rencana kesiapsiagaan dalam menghadapi akan apabila ada kejadian bencana gempa bumi dan tsunami di Kabupaten Minahasa. Karena melihat dari sejarah kejadian bencana, kemudian tadi ketika melihat pemaparan dari Prof bahwa Indonesia memiliki rawan bencana gempa bumi, terlebih juga gempa bumi yang ada. Nah, ini kami ingin ada masukan dari Prof dan juga teman-teman akademisi yang ada di tempat ini, agar supaya ini akan menjadi masukan kami dalam rangka penyusunan rencana kontingensi ini untuk kami membuat suatu skenario terburuk yang bisa terjadi di Kabupaten Minahasa sebagai langkah antisipasi kami, sebagai antisipasi dari pemerintah dan masyarakat untuk menghadapi akan bencana gempa bumi dan tsunami. Dan juga di Kabupaten Minahasa memiliki daerah rawan likuifaksi. Nah, ini yang juga menjadi perhatian kami semua. Jadi ada suatu masukan kepada kami untuk membuat suatu skenario yang terburuk dari dampak bencana yang bisa terjadi untuk bisa kami menjadi antisipasi baik pemerintah dan masyarakat yang ada, yang nantinya akan dibuat dalam suatu dokumen yang namanya dokumen rencana kontingensi. Itu karena untuk bencana gempa bumi yang ada di Minahasa dari risiko yang sangat tinggi. Nah, kebetulan Kabupaten Minahasa untuk kategori bencana, Kabupaten Minahasa berada di urutan yang pertama dengan indeks risiko bencana yang tinggi. Jadi dari 15 kabupaten kota, Minahasa yang urutan pertama. Ya, ini memang urutan pertama yang terburuk Pak ini. Ya, jadi memiliki risiko yang sangat tinggi. Nah, ini yang kami akan coba untuk membuat dokumen rencana kontingensi yang nantinya akan menjadi sebuah rencana yang memang kita harapkan itu dokumen tidak akan digunakan. Ya, tapi dokumen itu harus disiapkan dalam rangka kita mengantisipasi dalam bentuk kesiapsiagaan kita untuk menghadapi dampak terburuk, dampak bencana dari gempa bumi. Mungkin itu dari kami. Terima kasih.
Terima kasih Pak Joy. Prof. Haris, he talk about the preparation of them next year will make a document of the contingency plan for earthquake and tsunami, because there were several tsunamis happen alongside the coastal area of Minahasa, mostly related to the eruption of volcano, underwater volcano in Sangir, and also earthquake, big earthquake. So he asked about your suggestion about that one. But tapi memang Pak Joy, sebelum ke arah contingency plan, kajian resiko bencana dokumennya dan dokumen rencana penanggulangan bencana harus segera disiapkan, baru bisa ke contingency. Iya. Okay, that's all. Maybe any suggestion for them,
So,
Prof. Haris?
I just want to make one comment. We need to make a shift in our perspective with respect to the government agencies. For example, I've been working with BPPD and BNPB ever since they were formed, and most people perceive them as coming in after. Not doing anything before, but coming in after. And I was in the BNPB office in Jakarta 2 days ago, and they had a video going, and on the video they show the BPPD and BNPB people, helping the sick and bringing supplies. That's not what it's about. It's about doing stuff in advance. They need to show a video of planting trees between the coast and the city, or doing evacuation drills, or that kind of stuff. The whole shift from disaster preparedness versus disaster relief needs to happen. If the BPPD and BNPB are a disaster relief agency, then who's going to do the preparedness? Yeah, it's a problem. I've talked to the head of the BPPD before about this, because I was at a talk that he gave, and his whole talk was about going in afterwards and helping all these people. I was like, wait, who's doing the preparedness? You're doing the relief.
Prof. Ron tadi memang menggarisbawahi ini kritik bagi kita semua. Pemerintah cenderung fokus pada pemberian bantuan setelah bencana terjadi, tapi tidak berbicara tentang bagaimana preparedness-nya, kesiapsiagaannya, selalu ke respons. Because it's cheaper to prepare than to respond.
It is.
Ya, karena lebih murah untuk prepare dibanding respons. Tapi kecenderungan pemerintah kita fokus pada yang mahal. Dan itu tercermin dari SPM. Realisasi SPM di Sulawesi Utara, 5 besar terendah di Indonesia. Minta maaf saya harus buka tentang hal ini. 5 besar terendah di Indonesia. Tapi di antara 3 SPM wajib BPBD, ternyata yang sedikit lebih bagus itu yang respons. Artinya mereka mau yang mahal, bukan mau yang murah. That's the problem. Itu yang harus kita akademisi kritisi dan memberikan solusi. Mungkin pertanyaan terakhir, 2 pertanyaan terakhir kita gabung sekali. So the last 2 question, Prof, and you will answer 2 saja. Ada yang satu siapa? Ada lagi satu terakhir. Oh.
Terima kasih untuk kesempatan. Izinkan saya menggunakan bahasa Indonesia. Because I make mistake when I speak English. Nama saya Bu Trene, dosen prodi geografi. Saya bertanya ini untuk kebutuhan pengembangan bidang studi saya. Berkaitan dengan zona subduction zone. Apakah memang selama ini diketahui pengaruhnya karena pergerakan lempeng? Saya ingin tanyakan apakah lewat kajian-kajian Prof ada hal lain yang berpengaruh. Khususnya Sulawesi Utara kita kenal ada 3 patahan yang besar. Pada pantai timur laut di Lembe, kemudian patahan Kema Belang dan Kema Manado dan Amurang Belang. Jadi berkaitan dengan ini, apakah ada faktor lain berdasarkan kajian yang baru-baru ini selain karena pergerakan lempeng? Itu aja, mohon maaf memang untuk konsumsi saya sebagai pengajar materi ini. Terima kasih, thank you very much, Prof. Saya kembalikan kepada moderator.
Terakhir Arsenta.
So, you translate that?
Yeah, I will translate. Silakan Arsenta.
Izin bertanya menggunakan bahasa Indonesia. Sebelum masuk ke pertanyaan ini, izin memperkenalkan, nama saya Arsenta Tumengkol. Saya juga mewakili dari tenaga pengajar dosen di jurusan pendidikan geografi maupun ilmu geografi. Kita yang mewakili geografi memang sudah ada mata kuliah baik pendidikan kebencanaan sebagai pengantar maupun manajemen kebencanaan dan juga mitigasi, yang terlibat langsung juga ada di depan Nermersi, Nerjoy dan juga Bapak Cahyadi pun saya. Konsen kita ke yang kaitan kebencanaan tadi sudah banyak yang pertanyaan yang mengarah ke lingkup dimensi. Memang dimensinya kompleks antara kaitan fisik, sosial maupun ekonomi yang membentuk untuk paradigma kebencanaan dan juga yang paradigma ini yang berkembang untuk di Indonesia sendiri, karena ini sharing dengan kita sudah turun-turun ke atau mendapat undangan dari kabupaten kota pun dari instansi Badan Penanggulangan Bencana di daerah, yang konsepsi yang berkembang kaitan pengurangan risiko bencana. Dan yang faktor yang digarisbawahi secara nasional seperti Nermersi katakan tadi, yang kaitan itu kesiapsiagaan ataupun kapasitas masyarakat. Karena yang untuk bencana konsepsinya antara faktor yang membentuk yang ancaman maupun kerentanan dan kapasitas itu yang paling jadi tantangan untuk selain di Indonesia, di kitanya yang di Sulawesi Utara, yang kaitan kapasitas memang itu yang rendah, sehingga tadi ada muncul pertanyaan kaitan kesadaran ataupun tadi dari menanyakan kalau lingkup dari orang pendidikan apa yang untuk orang mau kritisi atau yang masukan. Jadi yang untuk pertanyaan saya mungkin ini cuma sharing yang untuk pengalaman dari yang Prof dan tim, semisalnya yang tadi mungkin sempat di akhir paparan meneruskan ada program yang kaitan untuk yang pengurangan risiko bencana yang berbasis komunitas, ataupun contohnya misalnya yang orang bisa adaptasi untuk kebutuhan selain yang sistem peringatan dini, semisalnya walaupun berbeda benua, misalnya kita karakteristik di Indonesia berbeda bencana dengan di Eropa ataupun di Australia ataupun di benua Amerika, itu kalau sudah terlaksana efektif, apakah ada contoh yang boleh orang adaptasi atau adopsi di sini? Semisalnya yang kalau di Amerika kan yang karakteristiknya semisalnya bangun bunker ataupun karena yang angin atau yang topan itu, jadi contohnya yang menyesuaikan karakteristik yang di Indonesia kita khususnya di wilayah Sulawesi Utara, apa yang bisa menjadi masukan untuk yang lingkup yang paling sederhana untuk yang peningkatan kapasitas tersebut.
Okay, I'll try to summarize long questions from both of them. The first question about the fault in North Sulawesi. Any information about the fault?
About the
fault?
The fault?
Yes, in North Sulawesi.
Okay,
because
so the fault offshore or onshore?
Offshore.
Offshore.
Yes. That's the first question. And the second one related to the
the formulae of disaster risk, because the hazard and the vulnerability will be divided by the capacity. So capacity plays an important point to reduce the disaster risk. It means any success story from states about he mentioned about technical things, mitigation, the physical mitigation. Any suggestion or any success story using the physical mitigation in states in facing hazards. That's all.
So the first question about the fault zone. So the subduction zone, which is north of us, it's about 100 kilometers offshore. We don't know a lot about it because there's just not very many earthquakes. And we think that's because it's stuck. In order for us to test that, we need to determine if there's deformation around Manado by using GPS surveys. But we have to assume that it's stuck. And when it's stuck, it's not giving us hints about what its geometry is or what its slip rate is. And so we don't know a lot about that subduction zone. For example, to do a tsunami model, we have to make all kinds of assumptions that we can't constrain. So there's a lot of different options with the models we have. So to just look at one model is probably not the best way to understand the fault. We need to make several and then integrate them to see which one works the best. But it is a seismic gap. And that means that the longer it waits, the larger the event's going to be. So it's not good news when we have a seismic gap. It's bad news. The other question, I'm not sure what the question was.
The success story using the physical mitigation mechanism in facing hazards.
Oh, success stories.
Yes, like from states maybe.
Yeah, so I shared the two I've been involved in. It's really hard. We're trying to find a way by talking to BNPB or BPPD to collect success stories of people that have allowed or have achieved risk reduction. But right now it's hard because the news will only report the disasters, not the risk reduction. Yeah. Okay, thank you.
Oke, terima kasih Prof. Ronaris. Bisa berikan tepuk tangan. Thank you Pak Ron for your amazing explanation and presentation. And now we wanna make give a certificate. After that, we wanna make a family photo together. Yang di belakang yang posisi bagus. Oke, family photo. Para dosen, pimpinan.
Oh iya. Next, dosen-dosen yang lain yang belum berfoto mungkin berfoto dengan Prof. Boleh gantian aja ke depan yang belum ada foto. Supaya ada bukti dengan Prof. Iya. Nggak dapat penelitian mungkin boleh gelombang 2 ya kan. Bisa diusulkan ke rektor. Jadi yang belum dapat penelitian ya ada harapan. Jadi boleh. Nanti bisa diusulkan ke rektor untuk tahap 2. Jadi nanti boleh melapor. Asal ada bukti foto.
Thank you.